let's try to move this up too. Is that any better? All right, I'll try to speak up as well. All right. So we had an interesting talk this last hour. Who here was here for Spencer's talk? Okay. So I'll quickly do a quick overview for people who weren't here for that last talk. Spencer and I both work at HP. I work fully upstream in the OpenStack infrastructure project, and he works, spends about half his time working downstream in an OpenStack team within HP that consumes our infrastructure. So his talk was largely talking about the downstream side, ways that they were consuming our infrastructure. And my talk is talking about the same thing from the upstream side, but with a deeper dive into exactly what we've done with Puppet to make it more consumable by other people. So I called this talk Fully Public Puppet, because instead of just releasing individual modules to the community, we've open sourced our entire configuration. So you have an example that works in production, and you can look at how we've set things up and pretty much duplicate it. So this is my first FOSDEM. It's very exciting. But I've been a Linux hobbyist since about 2002. I got my first job as a junior sysadmin, where I was racking servers and doing on-site installs and all that kind of stuff in 2006. I'm a contributor to Ubuntu, Debian, and OpenStack. Those are the big projects I work on in open source, usually from an ops and packaging side. So in Ubuntu, I do a few community things, and then I also host a bunch of servers for community members to use and put stuff on. In OpenStack, I'm on the infrastructure team, which I'll talk about in a moment. And as I say, we've open sourced our infrastructure. We have over 100 projects now. I actually looked this morning. We have 109. I can bring up this link. Is this here? So if you start looking through this list, these are all projects. These are all things that we're running in our infrastructure. One of our policies is that everything that is used in the OpenStack project has to be an open source project, partially because we have a huge community of contributors from various giant companies. And we don't really want to step on toes by preferring one company's product over another, because inevitably, if we're using a product on the market, they're probably somehow involved with OpenStack somehow. So we don't really want to put up a barrier between the people who are consuming OpenStack. We also always wanted our infrastructure to be an open source project, and to be an open source project ourselves, we have to use all open source components. So in some cases, we've pulled things in. We use Jenkins for our continuous integration system, and Garrett for code review interface. And then we've written a bunch of stuff, which we've open sourced. Also, if you scroll down a bit, we have a ton of Puppet modules, which I will talk about in a moment. These were all, most of these were actually recently split out, which I'll talk about. Oops. That went away. Ah. That's better. Oh yeah, I wasn't sure if we had an internet connection, so I made a screenshot. So a few reasons why we did this. So Spencer's talk talked about us having a downstream, and some people actually are consuming our infrastructure. So that's an obvious reason why we'd want to do this. But more generally, perhaps you're not an open source project. You maybe have infrastructure internally, and you're on the ops team, and no one else ever sees that infrastructure, but they're using it every day. You may also be someone who is working on an open source project, and you put your Puppet modules online, but maybe your documentation isn't great, because a lot of modules aren't. I routinely download modules and then have to sort of figure out what they want in their variables. Like if they want an SSH key, I have to sort of dig into the manifest and find out whether they want a file or whether they want just a string or something. You know, that's just the SSH key. Whether it's a public or private key that the thing's looking for. I mean, it's obvious from looking at the manifest, but then I do have to dig in and find out where that is. So in our infrastructure, since we have everything online, you can see examples of what we're actually running. We found it also encourages better practices if everyone's looking at our stuff. It can be easy for working on Puppet modules and working on internal infra to hard code everything in and to copy in modules. But when everyone's looking and people are consuming your infrastructure, you end up doing things a better way, especially when you're doing code review like we're doing on everything. So everything that goes into our repository is peer reviewed. So for us, when we finally did the upgrade to Puppet 3, which was actually in September, about 2 weeks before 2.7 was end of life, even though we were really, really worried about it, the upgrade actually went pretty decently because we had already been doing sort of best practices when it came to Puppet. For us, this is a big one, allowing others in your organization, or in our case, all of OpenStack, or pretty much all of the internet, to suggest changes. If you're running this inside of a company and you've open sourced your infrastructure, sort of the company, you put a Git repository up somewhere, it allows other people in your organization to understand your infrastructure by looking at what it does. And then if they really have a pain point in their workflow, they can look at your configuration, they could submit changes, or submit more intelligent suggestions for changing things. In an organization that has a lot of developers, this is really helpful because the priorities of the ops team may not fully match the priorities of the developers. So the ops team may not have time to write a Puppet module for the thing the developer wants to deploy, but if the developer wants to take it unto themselves, they can go ahead and write a module and have ops deploy it. This works out really well in OpenStack, since again, there's a lot of companies investing time in OpenStack and money. So they all have their own interests. And then of course, people on the infrastructure team, we have our interests as well. The people on the infrastructure team can come from a variety of companies. And we can't really play favorites as to what's coming in next. So allowing the rest of the community to submit changes to our infrastructure has been super important. If anyone has questions throughout, just raise your hand. We're also really hyper committed to open source in our infrastructure team. A lot of us have been contributing to open source for a very long time. A number of us sort of took this job here because we were sysadmins and we really loved open source. My last job was just a regular sysadmin job. We were deploying for museums and small medium businesses, doing mail servers and web servers, all kinds of things. And when I went to look for a new job, I was like, dear internet, I'm a sysadmin who loves open source. Is that a job? Turns out it is, and I got one. So we're all really committed to open source, and we think sharing is nice. So we open sourced our whole infrastructure because we believe in that, and we wanted our infrastructure itself to be an open source project. So now that maybe I've convinced you that this is a good idea, I'll go into a bit about how we've gone about doing this. Some of this we did sort of from the outset. Other things we've had to learn along the way. If you're here for Spencer's talk, the state of things about 8 months ago is much different than it is today, now that we have a very active downstream who's working with us. So the first thing is to prepare some policies inside your infrastructure. For us, it's easy for us to say we want an open source policy. Everything we use has to be open source. Of course, that's not really a reasonable thing for a lot of companies. So if that is not the case, I'd first segregate out the proprietary from your infrastructure and don't open source that part. Even if it's just configuration files, I think the jury is still out on whether you're allowed to share proprietary configuration files, because licenses on those are very unclear. They could be the license of the rest of the software that you bought, but you don't really know, and you can ask your vendor, and they may be like, what does that mean, license on a config file? But you may not be able to share it. So make sure the proprietary stuff is outside of whatever you're open sourcing, and that you're not in violation of any licensing for that. But the open source stuff, it's all easy and fine, so you can keep that in the open source part. So licenses and config files. The Puppet modules on Puppet.forge are great because they do have a license. But sometimes when you find them on GitHub, they don't. I've had to email authors of licenses, or authors of modules a few times, either because their license is not clear, They may mention it offhand in a README, but that's not actually enough for us to use it because we want it to be clear. So I've had to submit patches to add a license file and email authors and be like, confirm that this is an open source project. Don't make me do that. It's a waste of both of our times. If you're putting it on GitHub, it's probably an open source thing. And a lot of people don't think about licensing config files, but we're sysadmins, and that's something we have to start thinking about if we're not already. So directly on the Puppet side, one of the things you should be doing generally is using existing modules. I think we all know this, even if we don't necessarily do it, or if we're forking modules. We've done our fair share of that. But you should try to use the modules that exist. If they're not working for you, try to work with upstream to make the module better. If you have to fork it, that happens. We forked our Apache module, and now we're in a big mess. The MySQL module is good, though. And then when you write your own modules, this is something we've struggled with as well, writing them with the intention of sharing them with others. So I wrote this review day module a while back, and it should be able to be used by anyone who's using bugs on Launchpad, because it hooks in and tries to, and who's using Garrett. So it hooks into a Garrett and Launchpad and tries to determine sort of the heat of a code review. So trying to get developers to hone in on the reviews that are most important in their queue. So if people happen to be using ours, hopefully they can use my module, and then we share that. And then you want to keep these outside of your your general configuration. So early on, we had this monolithic thing we called config that had a modules directory in it, and that had all of our modules, all the ones that were listed on this page, like this, the review day and review stats and all these things, or no, the Puppet ones, yeah. So like, planet and all review day, and these were all inside of our monolithic config. So if someone wanted to consume our stuff, they had to download that whole huge thing, which included all this stuff that they might not want. But we split that out. And then have a separate configuration, which I'll talk about in a moment, which is here. So in our infrastructure, we learned that instead of having a single config, we actually wanted something that is our infrastructure config, which we've called our system configuration. So that's all the definitions for all of our servers in our infrastructure, and how to pretty much duplicate our infrastructure server-wise and service-wise. We then have project configuration, which is all of our Jenkins job definitions, everything that we're sending to Garrett, all of the OpenStack specific stuff. And I can show you. Let's see. So if I go, where is system config? Right. So system config has things like our install modules and Puppets files. These prepare all of our nodes that we need. And then we have this OpenStack project module, which has manifests for all the servers that we use. So it shows you how to set up cacti and bots and other things. And these are things that other projects can consume, and they can sort of pick through this list of what they want to use and then consume it in their own infrastructure. Probably call the module something other than OpenStack OpenStack project. Oh yeah, and then we have the project config. And this has, again, all the really OpenStack specific stuff. So we have a Garrett projects.yaml. Oh, there we go. That defines all the projects in OpenStack. So if you were running your own Garrett, you'd want to set up a project config that has all your definitions. So again, we split this out from our configuration, our system configuration, because we don't want to ship all of our OpenStack stuff with the thing that we're shipping all of our system configs with, because they are very separate things. And you might not be working on OpenStack in your continuous integration environment. And this is something we did fairly recently. We actually have a specification for it, which in OpenStack is sort of a plan for how you're going to do something. So we were in a bad state earlier, and then we made a plan. It's this big, long page that you can read. I have a link to it later. And we went through work items. So sort of explaining to people if they wanted to split out similar things, this is what we did to do the thing that we did when we got into trouble. We also had to split out all of our non-sensitive custom configurations. So SSH keys, those are pretty private. Our host names on our servers, we don't care. Everyone can see those if they want. So in ours, this is an example of our Zool, which is sort of our queuing thing for tests. Patches in our review system go into Zool. Zool queues them up for testing in Jenkins, and then Zool also processes the results from Jenkins back into our code review system. So we have things like our status URL is status.openstack.org/Zool, but if someone else is working on this project, they're probably not going to have that URL because that's ours. And then we have all these things. These variables actually come from Hira, so they're the vhost and all kinds of different variables that we have here. So these are all split out into, these are all things that are split out into our config. So using a lot of variables. We use variables everywhere. We try not to hard code anything in. I think we've gotten rid of a lot of the hard coding now that we have a downstream who's actually sending us patches and saying, stop doing that. There was one actually when I started working on the project that hard-coded .org at the end of everything. And so when I was testing it on my own infrastructure at home, where my host name is a .com, that was a serious pain. I don't know why we assumed .org and not anything else, but it was the way it was. And then we use a tool called Hira for all of our sensitive data. That's the only thing we put in there. So our SSH keys, our passwords, all the user data. We have a funny story about how we learned that email addresses are personal data or secret, sensitive. Once upon a time, we said, we're an open source project. We post to the open source mailing lists. Our email addresses all over the internet. So they were not a sensitive data piece. We put them in our infrastructure code. Does anyone know what happened? No?
Password resets were sensitive?
No.
Support requests for third-party projects?
Yeah. So he said support requests for third-party projects. So it was sort of related to that. It was people downloaded our modules and installed them, and then their infrastructures would start emailing us all the data. Yep, so we knew about all these infrastructures that were being launched. We're like, oh, cool, there's one at that company. That's interesting. I wonder where that IP is coming from. So we decided to save people from themselves, and we took out our email addresses and make people do it themselves. So that was very fun. And then, of course, the support requests, people joining our channel and being like, hey, so-and-so's infra's not working. And we're like, what? They're running an infra, cool. So email addresses, sensitive data in Puppet, because people will download your Puppet modules, and they'll just run them without reading them. It's kind of scary. So one of the really cool things that we've done, we set up a dashboard called Puppet board. We used to use one that called Puppet dashboard, but it was stopped being used and it was deprecated. But Spencer actually came around and he showed us Puppet board, which is an interface for showing when changes are applied. So I can bring that up here. So it's a web interface. For us, anyone on the internet can get to it. It's puppetboard.openstack.org. We had to disable querying because that lets you figure out scary things about our infrastructure that we don't want you to figure out, like passwords. So if you're running this in the public, turn off the querying. And we've had to, for all of our stuff, since we're running this all on the internet, we've had to do similar things for other things that we run. But this was a big one in Puppet board. We had to turn that off. So I don't know how well you can see this. Oh, it looks okay. But every time Puppet runs, it updates the dashboard. We're using Puppet.mp4, the database backend for Puppet, which Puppet board queries. So every time a change is done in Puppet, you can see an update here. So I think I found one. Yeah, this is our Jenkins server. So this one actually was an error. It skipped a bunch of stuff. It failed on something. And oh, this is our Jenkins dev server. It's supposed to break. So in the last Puppet run, a bunch of stuff was skipped and failed and broken. But this allows us so that people who are submitting patches and getting their patches merged into our repository, these people are random people in the OpenStack project. They don't have shell accounts on our servers. They have no idea what's going on. They know that their patch was merged. They don't know if Puppet has picked it up yet. They don't know if the server's picked it up yet. And so by allowing them a peek into what's going on the servers through this dashboard, we make it so that they don't have to ask us. They don't have to sit in channel and be like, it hit the Git repository 25 minutes ago. Why isn't it showing up? And they're sitting there hitting refresh in their browser to see if their change has taken effect. Instead, they can just go to the dashboard and they can figure out what's happened. You can also dive in to this a bit more to find out exactly why something failed. So if you click on something, it expands and tells you, could not retrieve this environment thing. So they can actually start writing a patch to go ahead and fix what broke, what didn't work in their patch, without again having to ask us in the infra channel or on our mailing list. So it really empowers our users who are submitting patches to do things sort of autonomously. And they don't need to ask us to sift through log files. And that's nice, because who likes to do that? So having a public thing is pretty cool. This is an example of a change that was successful. Yeah, so if you're scrolling down through here, you can find ones that are unchanged and changed. This is the failed Jenkins dev one I pulled up. So yeah, you can see pretty much when it was last run and if your change was taken effect. And then the final step is sort of sharing this. It's great to think your infrastructure is open source because you put it up on a Git repository, but you also need to tell people about it. And as I mentioned before, add a license to it, because then people don't need to ask you. And then you need to document it. This is very important. You need to tell people where to find it. So the links to your Git repository, your GitHub, or whatever you're using. You want to give them a workflow for using the configuration. So something that we've done is we have so we have a ci.openstack.org. This is where all of our documentation lives. One of the things that we do is we tell people exactly how to make a change in Puppet. So that's a lot of words, but if you want to contribute, it's probably good to read them. And then if you go down here, it actually shows you what steps to follow to replicate a standard node in our configuration. So this is assuming you're using Debian or Ubuntu. You install Git, you clone our system configuration, and then you create your local.pp, which would be your proposed change to our system. You'd run our install Puppet and install module scripts. That will get you the same version of Puppet we're using, and then download all the modules that we're using in our infrastructure. And then we give you a sample command you can use, a Puppet apply command, to run your stuff. So then you can test that your change works against the infrastructure that we have. This has been super valuable to us because people are able to write modules. I mean, I was writing modules. I'm about to get shell access to our servers, but I don't have it yet. So I've been working for 2 years through a code review system where I'm writing Puppet modules for servers I've never logged into. And we want to make that possible for people because that is the way our infrastructure is built to run. Giving SSH access to everyone in the OpenStack project would not be fun at all, even if they don't have root. So document some sort of workflow so people can test their change against the environment that you have. And then give instructions for how you want to contribute. In our case, we use a code review system that OpenStack uses. So all of our contributions to our infrastructure are done in the same way they are for every other OpenStack project. In your case, it may be someone submits a patch on a ticket, or maybe on a bug report, or they actually have maybe direct commit access to your repository. That'd be scary, but some companies trust all their developers and all their ops people, and maybe that's how it works. But give some instruction on how to do the contribution. For us, I think we link that where. Oh yeah, we have a contributing spot here. We tell them how to go to our IRC channel, how to do all the stuff, and all the things here. And then explain sort of how the bootstrapping and glue of your infrastructure works. So how your system is set up. We have a few workflow things. I think we've got one. No, it's not here. Well, apparently I can't find it. That's very bad. Anyway, they're show people how the infrastructure goes together so they understand. So when they're submitting changes to your infrastructure, they have a good idea of what they're putting changes against. And so that's mostly what I had. So in the course of OpenStack open sourcing our infrastructure, I learned about other projects that are doing this. Debian, their Debian systems administration team, they do all their stuff in the open. They've been doing it for a really long time. I think they've been doing that for longer than most projects I'm aware of, having a pretty open team. They have Puppet modules that do some of their stuff. Mozilla has an engineering team that works on Puppet, and they've open sourced a bunch of their stuff. Jenkins infrastructure team, they're always interested in having more people contribute. So they have an open source infrastructure team too. One of the really great things about these infrastructure teams and the OpenStack one is that these are real, serious project infrastructures that are doing real things in an open source project. If you're a junior sysadmin and you're looking for some experience and you can't get hired just yet, I'd highly recommend volunteering with one of these teams. These teams mostly are, maybe not the Debian one because they don't hire people because they're Debian and they're an open source project. But Mozilla and Jenkins and OpenStack, they have companies who are funding most of their developers. And they're small enough now that if you start contributing to one of these projects, I'm thinking you'll probably get hired. Even once these get bigger and we stop hiring every single person who submits a patch to us, it's still very good real-world experience. You can definitely put it on your resume, and you learn from a real working production of Puppet. I hadn't really used Puppet a whole lot before I had this job. I'm not going to tell you what we were doing. It was horrible. No, we sent out config files and Debian packages that we maintained. It was scary. So when I started, I'd only played with Puppet, and then over the course of these past couple of years, I mean, I was writing my own Puppet modules within like 3 months of working with the infrastructure. So you learn really fast, and it's a great environment to work in. And then some resources I've mentioned throughout the talk are documentation, of course. The repository that has like 109 repositories in it now of all of our open source stuff. And then these two specs. Again, these were what we did. These were the plans for things we were working on. So I showed you the split out config one. And then there was also splitting out the Puppet modules. So we actually just finished this on Wednesday, so I was super excited to be like, look, we split out all our Puppet modules today. So, but we went through and we documented this. We had this big, massive monster, and if you have a similar thing, you can come look at our spec and see exactly what we did. Some of the cool things we did is we preserved history in the repositories. So if you look at one of our Puppet configs here, let's go find one. So let's find one, another good one. Hey, let's look at our XM module. So even though we just split this module out on Wednesday, we were able to use Git magic and actually pull out all the Git commits we had in our old repository, and we've documented how we did that. So even though this module is new, we have a history in Git, which is pretty cool stuff. So yeah, even though we did things sort of wrong to begin with, now we have specifications to tell other people also how to get out of that mess. So in some ways, it's good that we messed up. We learned a lot. And that's all I had. You have any questions? Oh, yeah.
Do you keep any closed source in OpenStack? Is there something that you are not sharing besides the?
Right. So the question is do we do anything that's closed source in the OpenStack infrastructure? Right. And if there's anything we're not sharing. No. We have a policy. We're from the OpenStack Foundation, who says we cannot use any closed source software in our infrastructure. Like, it might upset some of the people who are contributing to OpenStack, the companies, if we use, this tool over another tool, if we start paying for that tool. And also, we do want this to be an open source infrastructure that anyone can replicate. The one exception we have right now is we're using Transifex for translations. If anyone knows the story here, Transifex used to be an open source project. We were using their hosted version because that was good enough. But last year they went closed source. They no longer update their GitHub repo. So for us, it's no longer an open source project. So we're actually switching over to another tool called Zanata. So we actually have a specification up for migrating over to that. But that's only because we got stuck in this position where a company owned the source code and relicensed it, or all the changes were up to a certain point. They just stopped maintaining their open source code. So not intentional. Yeah. Why do we use Puppet and not something else? We had a really small team when we started, and the guy who was implementing it, he tried to get Chef running, and he got Puppet running first. I will say, I mean, Puppet is fine. If we were starting over, we'd probably use Ansible because we don't have to deploy clients everywhere. But we're already pretty much, if it we already have them everywhere. SSH is already there. We already have that set up because our servers have to talk to each other. But it works, and we don't hate any configuration management thing specifically. And this, I mean, I think a lot of the lessons here could be used for other configuration management systems as well. So, yeah.
OpenStack infra is huge. If I'm upstream for a smaller open source project, but I do need a backtracker, a Garrett, a Jenkins, a Meatball, like subset of those things, how feasible is to run just a very small subset of what you deploy?
Right, so the question was, if you're a smaller project, OpenStack is huge. We have like 800 test servers in our CI. How reasonable it is for a smaller project to consume some of this. It's actually quite easy, in as much as infrastructure is ever easy in continuous integration. A lot of the things are very pluggable. So we have a flow that goes Garrett, Zool, Jenkins. We wrote Zool because we have a ridiculous number of patches. Like, so many patches come through. Actually, if you look at, it's a weekend, so it won't be quite so busy. But these are timestamps on when changes were updated. So since it's a weekend, they're only updated about every 2 minutes or so. This is pretty slow day. But we have super active patch activity. So we had to write Zool because patches would come in and they'd conflict with each other and they'd hit the repository and they'd have conflicts. If you have a much smaller project where the patch sets, maybe aren't coming in so fast, there's a Garrett to Zool plugin that can be used, and we've actually documented that in some places where you can just use that instead of using our big Zool thing. So that's one of the scaling things that we've done. You can also, we're using Jenkins with a tool called Nodepool, which manages our fleet of 800 servers that are being used to run all of our tests. But you could just use Jenkins in the old model of just having it plugged directly into a fleet of servers you manage some other way. So it's totally reasonable to use different things, because we've really done things to scale up, but to use different plugins, because it's all pretty pluggable. And for things like our status bots and our upcoming bug tracker that we're developing, those are all, they can just be run in small batches too. So, anyone else? All right, cool, thank you.